So in grade 11, you're gonna have to deal with equations that have rational exponents, right? So an equation, right, is an expression that is equal to another expression. Yes, zero is also an expression, by the way. So if you have an expression that is equal to another expression, that is what we call an equation. So if you have two expressions that are divided by an equal sign, that is an equation. Sorry, two expressions that are divided by an equal sign, that is what we call an equation. So some of these equations are actually going to have an exponent that is actually rational, and this is how we're going to be solving all those equations that actually have a rational exponent. So now this is what you must keep in mind: x to the power of, let's just say, a over b is equal to okay, excuse me, let's just say c. So if a, you only look at the value of a. If a is an even number, an even number is 2, 4, 6, 8, 10, 12, and so forth and so forth and so forth. So if a is an even number, your answer will have two solutions. So being that this is going to be positive or negative. So the answer that you're going to have is going to be positive or negative, or you're going to have two solutions, positive and a negative. Provided that A, you don't look at B, you only look at A. If A is an even number, you're going to have positive or a negative. That is what is going to happen. But if A is an odd number, odd numbers are just 1, 3, 5, 7, 9, 11, 13, 15, and so forth and so forth and so forth. These are what we call odd numbers. If A is an odd number, so the answer that you're going to have there is just going to be positive only. So you're going to have one solution, and then that's it. So if it's an even number, you only look at the value of A. Please only look at the value of A. So if A is an even number, you're going to have positive or negative, two solutions. So if it's even number, two solutions. If it's an odd number, one solution. Yeah, it should be that easy. So let us just try and answer the first thing there. Okay, so here is the first example. So with the first example, what I'm then going to do is that I'm going to take with the first example, I'm going to take this 2 squared over to the other side, and then I'm going to have x to the power of 2 over 3. That will give me 2 squared. So then what I'm going to do at this point is that I'm going to observe the a, the number which is at the top there. So obviously the number that I have there is an even number. So since that number at the top there is an even number, I must just know that the final answer that I'm going to have is going to be positive or negative. That is how it works. The final thing should be positive or negative. So what I'm going to do now? So first of all, I need to get rid of this. So I'm going to say divided. I put an exponent that is actually a reciprocal. I don't know how to pronounce it, but reciprocal. So basically why I'm actually doing this is that I want to cancel this, but then there's a rule that says what you do on the left hand side, you must also do on the right hand side, right? So obviously that whole thing, you cancel that whole thing. So I have x is equal to, so now on this side, since I said that 2 is an even number, so we must start with positive or a negative. Whatever that you're going to have on the other side should be positive or negative. So now that 2, we cancel that 2. So what's left is 2 to the power of 3. So x is equal to positive or negative 8. Right? So that is how we solve the first one. Let's try the second one. Here's another one, right? So I have x to the power of 3 over 2 equal to, with 125, you still do that method that I taught you in the other videos. You're going to say 125 on your calculator. You press 125, you press equal sign, you press shift, you press fact. So then it is going to give you the factors. That is why we are actually doing that. It's going to give you the factors. So 125, it's 5 to the power of 3. So the calculator is going to give you 5 to the power of 3. Right? But what we then do in this step is that we are trying to get rid of this 3 over 2. You do the same thing that we just did in the other step there. you put the exponent of the reciprocal, so it's 2/3 like that, and then you also put 2/3 on the other side. Right, and then obviously that will cancel that. I have the x to the power of now 3. The number that is at the top is 3. 3 is an odd number, so that means you're just going to have a one solution. 3 is an odd number, so that means that as 3 cancels 3 on the other side, you have only positive as a solution, 5 to the power of 2. So x is just 5 squared. 5 squared is just 25. That is how we actually do that. Simple. Let's get to the third example. This one, I wouldn't say it's actually difficult, but then it's something that you haven't actually seen before. But then please just try and follow what I'm going to be doing now. Just try and follow what I'm going to be doing now. So now what I'm going to do is that I'm going to say x minus 3. And then I'm going to say 2/3 is equal to, now 9 is just 3 squared. So now what you must also know is that this 2/3 affects everything that is inside. This 2/3 is for x minus 3. Everything that is inside of the bracket, please don't forget that. So obviously what I must then do is that I must first analyze the value of my thing there, the value that is at the top, and I can see that it's 2. 2 is an even number. So if it's an even number, then I must just know that my solution is going to be 2. And my answer is going to have 2 solutions. I'm going to have 2 solutions as my answer, positive or a negative. Why? Because 2 is an even number. I've explained this in the beginning of the video. So what I must then do in this step is that I must try and get rid of this. And this is what I'm going to do. 3/2. I'm actually multiplying by its inverse to make sure that I cancel that. And what I do on the left hand side, you also do on the right hand side. 3/2. So now this whole thing cancels the whole thing, but then the whole thing actually remains. That x minus 3, that whole thing remains. So I'm gonna have x minus 3 is equal to, now here 2 will cancel 2. So now please don't forget the positive or a negative. Please don't forget that. Now 3 cubed, because 2 cancelled 2, what was left was 3 cubed. Now at this point, what you can then do is x minus 3 is equal to positive or a negative 3 cubed is 27. So now at this point, this is what you do. I don't know if like you've seen this before or not, but then it's fine. Just try and follow what I'm doing now. What you're then going to do at this step is this. You're going to say x minus 3 is equal to, then you first take the first solution there, which is positive 27. And then you're going to say, or x minus 3 is equal to the second solution, which was a negative 27. So that means that we're just taking all the solutions. The reason why we're doing this, because there was another number on the left hand side. If there was only just an x, then whatever it is that I'm doing now wouldn't have been necessary. The only reason why this is actually necessary is because there's a number or another thing that was like involved with the x, and I need to get rid of that. So now that means at this step, this is actually easy. I'm going to take this over to the other side. It becomes x is equal to 30, or x is equal to, then you take that over to the other side, right? And then becomes a positive. So now it is negative 27 plus 3, which is x is equal to negative 24. That is how it works, right? So that was actually easy. It was not that difficult. So you still do the same thing here. So watch what's going to happen now. As you can see, x is an exponent. I don't know if maybe they were trying to play mind games. This is also one of the rules from grade 9. Yes, grade 9. Yes, I remember now, grade 9. So x is an exponent. So obviously, if you're trying to solve for an equation and what you're solving for is an exponent, like just as we have what you're solving for. You're solving for x, and x is an exponent. Just make sure that you make the bases the same. Please do not get confused. The bases need to be the same if x is an exponent. So this is what I'm actually talking about. 3 to the power of x over 2 is equal to 9. It's just 3 squared. We all know that. So now, since my bases are the same, then so that means that the exponents are also equal to each other. Since the bases are the same, so that means the exponents are also equal to each other. So I'm going to have x divided by 2 will give me 2, so that means that x is just 4, right? Simple as that. Let's carry on. Here's another one. So what I'm gonna do, what I'm gonna then do here is I'm gonna say x to the power of 4 over 5 is equal to. So now since these two numbers, the 2 and the 3, have a common exponent, I can just factor it out like this. 2 over 3, then I can just put an 8 there. Doesn't really matter. And then now it is also important to notice again that the 4 is an even number. So if the number that is at the top is an even number, my final answer is going to have two solutions, a positive or a negative, right? A positive or a negative. So, but then before I get to that, I must get rid of that exponent, which is 5 over 4. 5 over 4 on that. So that is going to cancel that. X is equal to positive or negative. Please don't forget the positive or negative, right? And then 8 times 5, 8 times 5 over 4 should give me 10. So it's 2 over 3 to the power of 10. And then you can just leave it like this if you like. It really depends with you. It depends on you. You can just say positive or negative 2 to the power of 10 or 3 over 10. But then there's no difference with these two terms or these two forms. There's actually no difference at all. There's no difference at all. You'd actually get a mark for that, but then please don't forget the positive and negative sign. Those are very important, the positive or the negative sign. Right, let's get to the last example. This one might be a little bit difficult, but they're not exactly. Please just try and follow what I'm going to be doing step by step, step by step. So I can just know that a 4 is 2 squared. So I'll just say 2 squared times 3 to the power of x divided by 2. That will be equal to 9 is just 3 squared times 2 to the power of x over 2, right? So now it also can be confusing when you see an expression like this, but then if you see something like this, just know this, okay? Just make sure that you group your x's, and then anything that does not have an x, you take it over to the other side. So what I'm actually saying is that make sure that you bring all your x's on one side, and any number or anything that does not have an x goes to the other side, right? So let me do this step by step. So what I'm going to do is that I'm going to divide by, let me change the color there. I'll just divide by 2 to the power of x over 2 on both sides. 2 to the power of x over 2. So now that cancels that. Look at what I have left now. I have 2 squared times 3 to the power of x over 2 over 2 to the power of x over 2 is equal to now 3 squared, right? So now I can actually see that all my x's are on one side, but then I also need to get rid of this 2 squared. I need to get rid of this 2 squared, and that is also just simple. You just divide by 2 squared on both sides. Divide by 2 squared on both sides. There, we cancel that, right? Look at what I have left now. This 3 to the power of x over 2 over 2 to the power of x over 2. The answer is going to be 3 squared over 2 squared. So seeing that my exponents are actually the same here, I can just factor it out, and I can also do the same there because my exponents are also the same. So watch what I'm going to do now. I'm going to say 3 over 2, and then my exponent is x over 2 is equal to, and then I can also do the same there. It's 3 over 2. The exponent is just 2, right? So now I don't know if you still remember this other example that I made. When bases are the same, you make the exponents equal to each other. When bases are the same, you make the exponents equal to each other. So we can also apply the same thing there. Bases are the same. Bases are the same. You make the exponents equal to each other. So what you're then going to have here is x over 2 is equal to 2. Then x is equal to 4.